Hello everyone, welcome to Homework Hell. If you find the video useful, please subscribe to the channel. In this video, we'll solve a polynomial inequality. The inequality is x cubed plus 2x squared minus 19x minus 20 greater than 0. This is a cubic inequality. We have to find the value of x for which this cubic polynomial is greater than 0. The first step is to factor this cubic polynomial. We cannot use grouping method to factor this cubic polynomial, so we have to use rational roots theorem. The leading coefficient for this cubic polynomial is 1 because the coefficient of the x cubed term is 1. So the possible factors for this cubic polynomial can be found using the factors of the number term -20. The factors of -20 are plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, and plus minus 20. We have to find which of these values will make the value of this cubic polynomial equal to 0. We have to sub in these factors one by one in this cubic polynomial. Let's assume this cubic polynomial is represented by a function f at x. Now we can sub in the factors of -20 one by one in this function. Let's start with x equals 1. I get -36. The function value is not equal to 0. That means x equals 1 is not the number we are looking for. Next we should try x equals -1. I get 0. That means that x equals -1. The value of the cubic polynomial is equal to 0. So the first factor for this cubic polynomial is x plus 1. Now we have to find the other factors for this cubic polynomial. We should do polynomial division. We can do either polynomial long division or synthetic division. In this video, I'll do synthetic division because it's faster. For the synthetic division, the first step is to write the coefficients of the cubic polynomial. Next, we write the x value from the factor on the left side. Now we can start the synthetic division. The first step is to bring down the first coefficient. Now we multiply -1 by 1, which is equal to -1. We write the result under the 2. 2 plus -1 is equal to 1. Next we do -1 times 1, which is equal to -1. We write negative 1 under the negative 19. Negative 19 plus negative 1 is equal to negative 20. Next we do negative 1 times negative 20, which is equal to positive 20. We write that under negative 20. Negative 20 plus 20 is equal to 0. The last number we get is 0. That proves that x plus 1 is a factor of the given cubic polynomial. The degree of the cubic polynomial is 3. The degree of the first factor x plus 1 is 1. So the degree of the quotient for this polynomial division should be equal to 3 minus 1, which is equal to 2. We use the first three numbers from this synthetic division for the quotient for this polynomial division. So we assign x squared to the first one, x to the next one, and negative 20 is the number term in the quotient. Now we can write the given inequality in partially factored form as we start with the first factor x plus 1 times the quotient Next, we should factor the expression x squared plus x minus 20. This is a simple trinomial. We have to find two numbers whose sum is the coefficient of the x term 1 and product is the number term negative 20. Two numbers that satisfy these two requirements are 5 and negative 4. So we can write the given inequality as Next, we should find the x-intercepts for this cubic polynomial. We should set each factor equal to 0 and solve for x. There are three x-intercepts, negative 1, negative 5 and positive 4. Now we can use the number line method to find the solutions for the given inequality. We should start by plotting the x-intercepts. These x-intercepts divide the number line into four parts. We have to find which of these four parts satisfy the given inequality. We have to use a test value from each part. To the left side of negative 5, we can use the test value negative 6. Between negative 5 and negative 1, we can use the test value negative 2. Between negative 1 and 4, we can use the test value 0. To the right side of 4, we can use the test value 5. At x equals negative 5, negative 1 and 4, the value of the cubic polynomial is equal to 0 because these are the x-intercepts for the cubic polynomial. We have to find the x values where the cubic polynomial is greater than 0, not greater than or equal to 0. Therefore, these x-intercepts negative 5, negative 1 and 4 should not be part of the solution. This is a very important concept we need to understand to solve this type of problem. Now we can use the test values. Let's start with negative 6. We should sub in x as negative 6 in the given cubic polynomial. I get negative 50, which is less than 0. We have to find the x values for which the cubic polynomial is greater than 0. That means the interval on the left side of negative 5 does not work for the given inequality. Now we can use the test value negative 2. I get 18, which is greater than 0. Therefore, the inequality is satisfied in the interval between negative 5 and negative 1. Next, we can use the test value 0. I get negative 20, which is less than 0. Therefore, the inequality is not satisfied in the interval from negative 1 to positive 4. Next, we can use the test value 5. I get 60, which is greater than 0. That means the given inequality is satisfied in the interval to the right side of 4. Now we can write the solutions for the given inequality. The inequality is satisfied in the interval from negative 5 to negative 1 and to the right side of 4. We can write the solution in inequality notation as we should not include the x values negative 5, negative 1 and 4 in this solution because at these x values the cubic polynomial becomes equal to 0. We can write the solution in interval notation as this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.